Hello everyone. Today myself Sanjay Verma, solution specialist in water and wastewater, talking from Capricorn Technology, bring you to a weekly insight on how we are going to simulate the situation where a change in pressure affect the quantity of water used with help of pressure dependent demanding water gems. So before going demonstration of the pressure dependent demand video, I just want to give a brief intro about our company. So Capricorn Technology is a Win Zero company which is having a legacy of over 3 decades, has now become a partner of choice for the AEC industries. Capricorn Technology is one of the biggest platinum partner of Autodesk and Bentley, along with authorized training center. So today with over 10 offices across India and to 20 Spire team members, we are serving over near about 20,000 customers in the building infrastructure manufacturing, along with a large number of other industries as well. So these are the some of the features that we shall be discussed during this insight, like understanding the concept of pressure dependent demand in WaterGEM, then how we create a scenario that assign a pressure dependent demand function to an alternative, and lastly how we are going to review the result. So the importance of this simulation help us to identify the area with pressure and how it affect the quantity of water used. So now I'm just switching to the software and we are going to have a live demonstration on this. Okay, so let's suppose this is a distribution network sample and we have to provide a pressure dependent demand within this network. So basically pressure dependent demand are used to simulate situation. So where a change in pressure affect the quantity of water used. So today inside we are going to set up a model and then we are going to create a pressure dependent demand function and also the create a scenario that assign a PDD function to an alternative. So generally in this insight, we use this example of neighborhood that receives water from two sources is a wire that is near and the far end and both have the hydraulic rate of 150 feet. So in this insight, we will simulate the system without considering the pressure dependent demand and all element operating. So first, what we are going to read, the near source is like we can see that the near source is on the left and the far source is on the right. So first, we are going to verify the current scenario. So from here, you can see that generally the scenario has been EPS, no PDD. Now I'm going to select as an steady, not pressure dependent demand. Once I select the steady, not pressure dependent demand, I'm going to compute the model and make sure the result are green. So my result are green. So next thing what I'm going to do is I'm just going to click on the report option and check a report for the junction table. Here, if we can see for the pressure column, so the highest pressure is 60.3 and the lowest is 43. So we can say that the pressure is being ranges from 43 to 60 psi. So I'm just going to close it. Now what I'm going to do is do I'm going to select as an EPS, not pressure dependent demand as an current scenario. And now I'm going to compute the scenario. The first we have selected the steady state and the second one is EPS. So I'm just going to compute the result and making sure that the result are green. So my result is being green. Now I'm going to here present a graph for both the reservoir. So how to do that is just press a control key and click on one reservoir which is at the near end and the second reservoir which is at the far end. Once you select both the reservoir, just right click on it and you can see there is an option graph. So once you open the graph, this type of dialog box for the series option will be appear. So let's suppose I don't want my graph to be on hydraulic rate. I want to be as a flow outlet with respect to time. I'm just going to click OK. So we can see that the graph for the same has been appear, and it's showing that the blue one is near for near reservoir and the red one is for the far reservoir, and the graph indicating the flow relative to time. You can save this graph also. So for saving this graph, what you have to do is just go to here, add to graph manager, and you can rename it. I'm just going to rename it as an, let's suppose, source flow, and okay. So your graph is being saved. I'm just going to close this option. And if you want, you can also remove the background layer. Here is the background. You can just uncheck this. So the drawing will look like the following. And if you not having a background layer here, you can go under the view option. Then there is a background option also. From there, you can untick the background layer. Now what I'm going to do is, now I'm going to setting up a pressure dependent demand function. So for that, what you have to do is go to the component tab. Here we can find a more option. Just click on it. And there is a pressure dependent demand function. Just click on it. So once you click on this option, you will find the dialog box for the pressure dependent demand function will be appear. So obviously we are going to provide a new pressure demand function. So we just going to click on new option, and I'm gonna rename it as, let's suppose, power function. And from here you can set the pressure threshold value. So you can set it according to your need. So I'm just random value. I'm going to 40 psi and just going to close it. Now the concept of scenario alternative is come. So for that you have to go alternative option. Here alternative option, there is an option. There should be a 15 type of alternative, but we are working with the action of pressure dependent demand here. So I'm just double click on it, pressure dependent demand, and under the global function option, we can see that we have just created a one pressure dependent demand function with the name as a power function. So I'm just clicking on it and assigning the value and close it. Now I'm going to run the model with the pressure dependent demand. So for that, we all know that the scenario option is there. So once we click on the scenario, we'll find that it says having a EPS for no pressure dependent demand. So what we have to do is I'm gonna create a new child scenario for EPS, because it is for not pressure dependent demand, but we are here doing for a pressure dependent demand. So I'm just going to create a new child scenario and rename it as an EPS pressure dependent demand and enter. So once I double click on it, you'll find a property for the same at the right window of my laptop. So just here, if I go to the last options in calculation option, steady state EPS solver, here is the thing is assigned it as an EPS not pressure dependent demand. So just I'm clicking on it and I'm going to create a new scenario, new calculation option, which will be named as an EPS PDD calculation for the same the scenario I have just created. I'm going to click OK. So this is how you can save the calculation option for the EPS PDD calculation. Now I'm going to analysis option. Here is you can find the option tab. Here you can see that the thing that I have just created under the property for the same has been here in the calculation option dialog box, EPS PDD calculation. So once I am click on it, we find a property for the same at the right window of my laptop. Then of course we have to set the time analysis under the calculation time. It is steady state, but we are here simulating for EPS purpose. So I'm going to select as an EPS. Start date you can select by your own. I'm leaving it as an remain same. Then I'm just going downward here. So here you will find in hydraulic use pressure dependent demand is generally false. So I'm just going to true this nature, and also make sure that pressure dependent demand is being selected for all nodes. Then I'm just going to click. Make sure that the EPS PDD function is incorrect. So I'm just going to select from here as an EPS PDD, and I'm just going to review the result. I mean, I'm going to compute the result. So my result is being true. And as we remember that we have saved one graph named with source flow. So once you go to the graph option, here is open source flow. I'm double click on it, and till it's showing the near EPS and we have simulated for the EPS for pressure dependent function demand. So I'm just here going to click on series option, and here in series option I'm going to tick mark both the EPS NOPD and EPS PTD function to see the graph result. I'm just clicking on OK, so we can see that for near and far EPS, which is not pressure dependent demand, and for pressure dependent demand, graph has been appear. So generally there are 4 lines on the graph, but only 2 are visible. This is because the lines for both the scenarios are identical. And just click on the data tab to, if you wish to see that the pressure did not drop below the reference point. So from here you can see the all the data. So this is how you can set a pressure dependent demand in water distribution sample. In next insight, we are going to work with this continuous, where we are going to running a non-pressure dependent demand model with the outage function. So thank you. So I hope you guys had an insightful session. So do subscribe to our YouTube channel for all update, and we would be delighted to hear from you. So do reach out to us for any suggestion, query, or topic you would want to discuss. See you next week with the next insight. Thanks and take care. Bye bye.